additive manufacturing of functionally graded ceramic components by using lithography-based ceramic manufacturing technologies can help to develop innovative, function-optimized medical implant structures.
The main advantage of this additive manufacturing technique is its high resolution. The fabrication of ceramic components using stereolithography-based methods delivers high precision and high density parts.
For this procedure, use high-purity ceramic powders with a mean particle size of less than 0.5 micrometers, a narrow particle size distribution, and a specific surface area of about 7 square meters per gram. In a grinding bowl, combine the powder and absolute ethanol in an 80-20 mass ratio. Add 1 to 2 mm diameter mill balls in an equal mass to the powder. Then, add about 0.5 to 2% by weight of dispersing agent, depending on the quantity of powder. Mill the mixture for 2 hours at 250 rpm in a planetary ball mill. Afterwards, remove the mill balls using a sieve with 500 micrometer openings. Let the suspension dry at room temperature in a fume hood for 12 hours. And then dry it further at 110 degrees Celsius for 24 hours. Grind the dry material through a sieve with mesh openings of 100 to 500 micrometers to obtain the deagglomerated functionalized powder. Next, in the can of a high-speed planetary ball mill, mix together a photoinitiator activated at the wavelength used in the printing device, organic cross-linkers and binders, and a plasticizer. Add 5 to 10 mill balls made of the ceramic material with diameters of 5 to 10 millimeters.